Welcome back. In our previous section, we looked at the late start and late finish of the different activities, and we ended off with the slide in which we updated the schedule table for late start and late finish. And the reason that is important is that we'll be looking at slack, which is our next section, which essentially looks at, it's also called float, and it's a difference between the early finish time of the last activity and the project required completion time. So it is the earliest time that the project finishes based on the last activity and the required completion time. So in terms of our market research study, clearly we don't have any float, any positive float in it, because there's two types of slack or two types of float. Negative slack is the lack of slack over the entire project. So in case of our example, there is negative slack, which means that we're already 8 days over the completion time for the project. The amount of time and activity must be accelerated. So in that case, we know that there's 8 days in which we need to find somewhere in terms of all of the different activities, in terms of where we need to accelerate certain activities. Positive slack is the maximum amount of time that activities on a particular path can be delayed without jeopardizing the on-time completion. Now, both of these, there's neither good or bad slack. There is just slack, which means that there's negative slack and positive slack. In terms of negative slack, it is obvious that if we are going to go over the completion time, it means two things. It means either we are overestimating the activity and duration times for different tasks to be completed, or the particular project completion time that our client has given us is unrealistic. So both of them tells a story. Positive slack means that we might have over or under looked underprepared and added too much duration or overestimated different activities and how long different activities will take place. And if you overestimate, that means that you end up spending too much money on activities that will take possibly a shorter period of time, because remember, in project management, time equals cost. So both of these, both negative slack and positive slack, tells you a story. Now let's have a look at the critical path. Remember back in chapter 1, we briefly touched on the critical path, and the critical path is the longest path in the overall network diagram, and it is which activities which have to have the least amount of slack, which means that those activities cannot be delayed. They have to take place, and they have to take place in the set time that you have allocated for them. So in the case of our market research study, we find that our critical path is this set of activities, which is activity 1, 2, 3, 4, 6, 9, 11, 12, and 13. These set of activities is the set of activities that must take place in order for the project to stay on track and be completed in time. When you look at your revised schedule, so now that we know the early start and we know the early finish, early start and finish, and the late start and finish, we can now calculate the slack. And how do we calculate that? So you'll see that in terms of the total slack is calculated as 2 days there, which is the difference between the finish and the earliest finish and the latest finish time. So it's 3, 5 minus 3, 15 minus 13 gives you 2, 35 minus 33 gives you 2, 40 minus 38 gives you 2. So in that case, you have what we call positive slack, and then you have negative slack for the other tasks. And what this then gives you an opportunity to understand which of the tasks you can accelerate and which of the tasks you can delay. Free slack is a time that a specific activity can be postponed without delaying the early start of its immediate successor activities, which means that there is a bit of space and a bit of leeway for that particular activity to be delayed before the next one starts. You have to find the lowest value. In order to calculate that, you have to find the lowest value of the total slack for all the activities entering a specific activity, and also subtract the value from the values of the total slack for all the other activities also entering into the same activity. So let's look at an example of a total slack compared to free slack. So let's have a look at activity number 7. There we go, activity number 7, and the total slack for activity number 7 is 50. And why is that? Because if we look at on which day activity 7 is 50, so if we look at Cebu can starts testing the software on day 10, and day input response data is on day 11, is on day activity is number 11, and then activity 10 is on day. So if we look at when the starting time is, you see that it takes 5 days for the testing of the software to take place, and the total slack is 50. The total slack for activity number 8 is 50. So it's 50 over there. Number 6 is 60, and number 7 is 50, and number 8 equals then a free slack of the difference between 60 and 50, which is then 10. Which means that essentially activity number 7 have an extra 10 days, plus minus 10 days, before it becomes critical. Make sense? You can also use a bar chart format to illustrate your planning and illustrate the flow of activities in terms of durations. You can list all of the activities down to one side, the person responsible, the estimated duration, and the entire length of the project running on the x-axis. So in this case, starting off day 1 through to day number 40. Remember that based on our calculation, the project will actually take 130 days, even though our client only wants it in 130 days. You can use different software in order to generate a bar chart, and also visually it shows you very quickly where the biggest time is going to be spent, the longest, which activity is the longest, and potentially where there are bottlenecks in terms of the overall project. That brings a close the first theme, and the next theme we'll be looking at project control. Thank you.